Hello everyone, welcome back to our channel Get Geomatics Engineering. In this channel we shall learn and explore geomatics engineering related domain. If you are new in this channel, then please go through our videos and subscribe to support us. And most importantly, give your valuable feedback in comment section for more improvement.
So today we are going to start a new topic, that is DGNSS, Differential Global Navigation Satellite System. The idea behind DGNSS is to correct bias errors at one location with measured bias error at a known position. What that means? If there are two stations, like one is base station and another one is rover receiver. So what the base station does actually, it mitigates the errors that are happening in the satellite navigation system and convey that error message to the rover receiver. That's how it can give a precise point positioning of a particular location. So that's how the DGNSS system occurs. At least two receiver is used in DGNSS positioning. So what are the use of DGNSS? That is the enhancement of GNSS system, and it is developed by the US and Canadian Coast Guard, used to remove error and get higher accuracy measurement, what I have told you already. And there are minimum involvement of two receiver, and that is a code based technique. There are various debates that sometimes the DGNSS and RTK system are called the same system, like someone says that DGNSS and RTK are same, but in DGNSS code based measurement is done, and in RTK system, real time kinematic, carrier based measurement is done. So here a diagram I have shown you for the understanding purpose that what is DGNSS, why it is different from RTK or precise point positioning or single point positioning. Like point positioning is a different kind of GNSS method, and relative positioning is a different method, but in some of the cases that overlaps with DGNSS, like precise point positioning. What happens in precise point positioning? First the positioning has done in the field, and then in the lab some error mitigation is done. So that comes under DGNSS because there are involvement of two receivers, that is a code based measurement. So that is also a DGNSS, but RTK cannot be a DGNSS because in RTK carrier phase measurement is done, but other relative techniques can be under the DGNSS technique. So what are the classification of DGNSS techniques based on characteristics? The receiver positioning differential. So based on the receiver, the DGNSS can classified, like there are relative positioning, relative static positioning, stop and go positioning, what I have already discussed, and relative kinematic positioning. So those can be comes under DGNSS also, those relative positioning, but not the RTK. The satellite positioning differential, that means the in between satellite differential, like in satellite positioning differential, the clock error can be mitigated. And there are frequency differential. Difference of signal propagation time for different frequencies is carried out in frequency differential. Like ionospheric delay can be mitigated through frequency differential. And there is another type of differential, that is time differential. The ambiguity error differential in signal propagation for different instants can be mitigated through time differential. So based on the characteristics, these are the DGNSS type, and this is the basic of DGNSS. Now let us move to the next slide. Now let us see how the DGNSS system works. Like, there are various methods. So I have already told you that based on the characteristics, the DGNSS system can be receiver position differential, or satellite position differential, or frequency differential, or time differential. So here what happens, the base receiver and the rover receiver should get signal from the same satellites, and based on that the base station calculate the errors and convey that error to the rover receiver. Now the base station can be a building, can be another receiver. If it is another receiver, then that is called the receiver position differential. If it is a satellite, it can be a satellite also. The base station can be a satellite also. If it is a satellite, then that is called the satellite position differential. It can be a radio frequency tower also. If it is a radio frequency tower, then it will convey the frequency in different time interval, and that is called the frequency differential. When same receiver is used in two different time, then that is called the time differential. So these are the processes, or these are the characteristics of base station based on which the DGNSS can be classified, and I have already mentioned that. Now let us see classification of DGNSS based on processing timing. One is real time, another one is post processing. So what is real time? Real time is any action that result in an instantaneous response. Like, you are roving with the rover receiver and you are getting the correction signal from the base station at that point of time instantaneously, then that is the real time DGNSS. And another one is post processing. In some cases, real time positioning the stationary receiver or the rover is not required. Like, in case of field survey, you may not require the base receiver at that point of time. You can take the position, come into the lab, and then you can process the signal to get the accurate positioning. Like, I want to make a map of an area, so I can collect data from the field and then I can post process the data in the lab. So if I have that facility, then I can do the post processing thing. So there are two type of file format for post processing. Like, in receiver specific data format, receiver and base station communication or error mitigation done through same specific data. Like, I have a receiver from a company and I can get mitigation information from the base station of that company only. But in receiver independent exchange format, the data format need not to be specific data format. It can get error mitigation information from any open source base station. So that is the difference between these two type of file format. Now let us move to the next slide. So based on the implementation, the DGNSS system can be classified in two types, that is autonomous system and inverted system. In autonomous system, the base station transmit correction information to rover receiver and rover receiver mitigate the error, but the both receiver works independently and rover receiver do not have any transmission facility. So that is the autonomous, that is the simple DGNSS system. And in case of inverted, the both base receiver and rover receiver communicate with each other and both receivers transmit correction information to mitigate error. As the base receiver is also involved in the signal transmitting, that the rover receiver is also involved in the signal transmitting. That's why it is called the inverted DGNSS. So it gives more accurate information than the autonomous DGNSS. So these are the two types of DGNSS system based on the implementation. Now let us see the accuracy of various GNSS system. According to some theories, the all four types of system that are shown here, like SBUS, precise point positioning, and real-time kinematic, all are in the DGNSS system. All comes under DGNSS system, because all of the system uses at least two receiver, so that is all are DGNSS system. But according to some other theories, that these four are totally different from each other, that DGNSS is that system which works in code based measurement, and it should have the baseline more than 50 kilometer, and it cannot have any satellite based differential positioning system, that is SBUS. So that is in that type of case, these four are totally different. The SBUS is augmentation system, and precise point positioning comes under point positioning, and RTK comes under relative positioning. So that is a debatable topic, but these are all about the DGNSS. So that's all in this video. So